Hey class, this is Mr. Roberts at Shasta High School, and I have two examples involving an arithmetic sequence and a geometric sequence. So definitely something from last semester, but it's related to our Delta Math assignment today. So first question says find the 91st term of an arithmetic sequence that has a first term of 28, a second term of 8, and a third term of negative 12. So we do know that this is always, when we're looking at these, right, it's always the first term, the second term, the third term, right? So when we're looking at a sequence, right, these are ordinal numbers, first, second, third, fourth. And if I want to figure out a rule for this sequence, and I'm going to need a rule because they want me to take this all the way out to the 91st term, I can look at my first two terms and I can say, look, if I go from 28, if I jump from 28 to 8, what's happening here is I'm subtracting the number 20. If I want to go from 8 to negative 12, I am subtracting 20. So each time the term number increases by 1, the sequence value goes down by 20. So you can see in 1, 2 steps, right, I subtract 40. So that value that I'm decreasing by, right, we associate with, because it is the same thing as it is our common difference, right? But it's also like the slope or the rate at which this particular sequence is changing. It might be helpful to look at a different representation. I could look at a table of values, and I can see here, oh, I've got my first term, my second term, my third term. This is 28, this is 8, this is negative 12. And I know that if this is the nth term, and I'm trying to find a general rule for the nth term, like t of n, I know part of it is that t of n is going to equal a negative 20 times the number n, because each time, right, I go up, I'm adding negative 20 to it. So negative 20 times n. The other thing I need is I need to know my 0th term, right? And if I know my 28th term, right, I can easily just go backwards, and instead of subtracting 20, I can add 20 to it, and I can get my 0th term would have to be the number 48. So now that I know my 0th term is plus 48, I can test this rule that I've written down for a few values and just verify, is it working? And you can see, if I was to look at our classroom calculators, one of the things I could do is I could look at its table functionality, and I could turn on a table and I can say, hey, the rule I think is negative 20. Here I'll use the variable x, and then plus 48. And I'm just going to say this table is going to start at the 0th term and increase by 1, and I just go. So you can see, yeah, the 0th term is 48, then we've got 28, then we've got 8, the one below that's going to be 12. And if I want to, I can go all the way down to the 91st term. This is not a great way to do that. I just like looking at this here because I can verify that this rule, right, this rule that we've written down is doing what it should do. And now that I believe in the rule, I can go ahead and find the 91st term by what? Taking negative 20, multiplying it by 91, and then adding 48 to that. So the 91st term, if I just do the arithmetic, let me quit the table. Oops. Second quit, it's going to be negative 20 times the number 91, and then to that I'm going to add 48. I get exactly negative 1,772. And just as a confirmation, I can go back to the table. The table's the same. And I can go, I'm just going to hit this until I get down to 91. Can I do it? 30. And I am now at term 81, 91. Yeah, negative 1,772.